Good afternoon to all. This is Satish Kumar, Assistant Professor of EC Department. Now let us see the another video lecture series on Laplace Transform. See, Laplace Transform represents continuous time signals in terms of complex exponential, that is nothing but e power minus st. Laplace Transform can be used to analyze signals which are not absolutely integrable. Continuous time signals can also be analyzed effectively by using Laplace transforms. Laplace transform of impulse response is called as system function or transfer function. See, Laplace transform of x of t can be denoted by x of s is equal to integral over minus infinite to plus infinite x of t into e power minus st into dt. Next, types of Laplace transform. It can be classified into two types: bilateral Laplace transform and unilateral Laplace transform. See, unilateral Laplace transform can be defined as x of s is equal to integral over 0 to infinite into x of t into e power minus st into dt. In terms of bilateral means, it can be denoted by f of s is equal to integral over minus infinite to plus infinite f of t into e power minus st into dt. Next one, relations between Fourier transform and Laplace transform. See, Laplace transform can be defined as x of s is equal to integral over minus infinite to plus infinite x of t into e power minus st into dt. In case s is equal to sigma plus j omega, you can replace. Therefore, integral over minus infinite to plus infinite x of t into e power minus sigma plus j omega t into dt. Therefore, integral over minus infinite to plus infinite x of t into e power minus sigma t into e power minus j omega t into dt. Therefore, x of s is equal to Fourier transform of x of t into e power minus sigma t. Therefore, sigma will get 1 means therefore x of s is equal to Fourier transform of x of t is nothing but x of omega. Therefore, s can be replaced by j omega. Next one, convergence of Laplace transform. Laplace transform is basically a Fourier transform of x of t into e power minus sigma t. If Fourier transform of e power minus sigma t x of t exists, means then Laplace transform of x of t also exists. Fourier transform of x of t into e power minus xt must be absolutely integrable. Therefore, integral over minus infinite to plus infinite x of t into e power minus sigma t into dt should be less than infinite. ROC means the range of value of sigma for which the Laplace transform converges is nothing but region of convergence. This is the representation of the signals from time domain to frequency domain. Time domain can be represented in terms of amplitude to time within terms of 1 kilohertz. That can be represented in terms of frequency domain. See, the one full wave can be separated into half in terms of 2 kilohertz. This relevant frequency domain representation can be given in terms of amplitude and frequency. Next one, find the Laplace transform of x of t into e power minus at into e of t and plot it ROC. Therefore, formula of Laplace transform is x of s is equal to integral over minus infinite to plus infinite x of t into e power minus st into dt. X of t is nothing but e power at into e of t. See, e of t condition means we can take in the limits from 0 to infinite. E power minus t, we can take it as common, s minus a into dt. Now we can differentiate and integrate. We can get 0 to infinite. We can get it as a 1 divided by s minus a. H should be greater than a. ROC is nothing but greater than a is the region of convergence. Then x of t is equal to e power minus at into e of minus t means similarly we can get the function by applying the formula. We can get the result as 1 divided by s minus a. S should be less than a. Therefore, e of minus t represents as s minus a. Therefore, a less than a part will be the shaded part is nothing but ROC. Next one, partial fraction method. Partial Laplace transform of e power at into e of t is nothing but 1 divided by s minus a. S should be greater than a. Laplace transform of minus of e power at into e of t is 1 divided by s minus a. S should be less than a. Laplace transform of e power minus at into e of t is nothing but 1 divided by s plus a. S should be greater than or equal to minus a. Laplace transform minus e power minus at into e of t is nothing but 1 divided by s plus a. S should be less than minus a. Therefore, applying the Laplace transform results here, e power minus t into e of t means 1 by s plus 1. Minus e power minus 2t into u of t means minus of 1 divided by s plus 2. E power minus t into u of t minus of e power minus 2 into u of t means, while we getting the applying the Laplace transform, we can get the result as 1 divided by s plus 1 minus of 1 divided by s plus 2. E power minus t into u of t minus of e power minus 2t into u of t means 1 divided by s plus 1 into s plus 2. Next one, we can see the applications. It is used in analysis of electrical and electronic circuits, breaking down the complex differential equations into simpler polynomial functions. Laplace transform gives the information about steady as well as transient states. In machine learning, the Laplace transform is used to making the predictions and making analysis in data mining. It simplifies the calculations in system modeling. From time domain to Laplace transformation, time domain linear differential equation can be given. From we can applying the Laplace transform, we can get the Laplace transform equation. By using the algebra, we can convert it into Laplace transform. By applying inverse Laplace transform, it can be converted to time domain sequence. Find the inverse Laplace transform of x of s is equal to 4 divided by s plus 2 into s plus 4. By applying partial fraction method, we can get the value as a is equal to 2, b is equal to minus 2. We can apply the inverse Laplace transform 2 by s plus 2 minus 2 divided by s plus 4. 2 into Laplace inverse of 1 by s plus 2 minus 2 of Laplace inverse of 1 by s plus 4. Therefore, x of t is equal to 2 into e power minus 2t into u of t minus 2 into e power minus 4t into u of t. Now we can see the assessment. Define Laplace transform. Laplace transform can be defined as x of s is equal to integral over minus infinite to plus infinite x of t into e power minus st into dt. The relationship between the Fourier transform and Laplace transform is given by x of s is equal to x of omega. S is equal to j omega. List the types of Laplace transform. It can be classified into two types: bilateral Laplace transform and unilateral Laplace transform. Define ROC of Laplace transform is nothing but region of the range of value of sigma for which the Laplace transform converges is nothing but ROC. Laplace transform of unit step function is 1 by s. Define convergence of Laplace transform for which the value of sigma converges is nothing but Laplace convergence of Laplace transform. Bilateral Laplace transform is also called as two-sided Laplace transform. Thank you.